to this question which is here. Express in the simplest form the number 2.3424. Now, I know we know how to do it. The first thing, just let this number be equal to x, right? That is going to be 2.3424. Now, make sure that the decimal number is in front of the repeating numbers. So it should be in front of the 24, that is the repeating number. So I need to multiply this equation by what? Who can tell us? We're going to multiply this equation by what? So that the decimal point goes in front of the repeating number. Yes, so multiply equation 1 by 100. So that will be x times 100, that will be 100x. And then 2.34 by 100, it will be 234. And then 2 for repeating. This will be our equation 2. Again, make sure that the decimal point goes behind the repeat numbers. So multiply now in this case equation 2 again by 100, since you only have two numbers after the decimal. So that will be now 10,000 x, and that will be 23424.24. I'll just put a dash on top. Okay. All right, just a 2 for, so that the numbers after the decimal in this equation and this equation are going to be the same. Always please do that. And then subtract 3 and 2. So this is going to be, we know, this is going to be what? This is a 10,000 minus 100. Okay, if we do that, 10,000 minus 100, that is going to give us 9,900 x. And here we're going to subtract, since this 24 and this 24 at the end, they're just going to cancel out. So it will be the 23,424 minus 234. And that is going to give us about 23,190. If we do the subtraction, like, it's not complex. 2, 3, 4, 2, 4. And then you say 2, 3, 4. You are subtracting this. So 4 minus 4, 0. Going to remove a 1 here, it remains a 3, it comes here. 12 minus 3, that is a 9. 3 minus 2, that's a 1, 3, and then 2. So that's the number. Then divide both sides by 9,900 to remain with x. 23190 over 9900. As simple as this. So that is going to be the answer. All right, the next one. Let I minus 2 over z be equal to 5 minus 2i squared. Find z, expressing your answer in the form p plus qi. So, the thing here is not to make sure that we do all questions. The thing is you make sure that you grasp the concept, because whatever the question they might bring, if you know just the concept, you are going to you are going to do it. The first thing is, I'm going to look at this part and just simplify it always. All right, if you've got something that is raised to a power like that, make sure that you simplify it. So the 5 minus 2i squared, remember what you said, get a first number, you square it, that is going to be 25. And then get this power 2 multiplied by the 5 and then multiply by the negative 4 to be negative 20i. And then get the negative 2 also squared, that will be positive 4i squared. I squared is negative 1, so this would be negative 4. So 25 minus 4, that is going to be 21, and then minus 20i. All right, that is it. So I'm going to rewrite now what I have here. I'm going to write it as, let, you've got I minus 2 over z, and this is equal to the 5 minus 2i squared. I'm going to put 21 minus 20i, since I've already simplified. Now, I want to make z subject to the formula. So I'm going to take z. Should I even do that? Okay, let me make it simple. I'm going to cross multiply. I'll say this is also over 1. I'll multiply this by this, and then z by that. So what we are going to have is z, open brackets, 21 minus 20i. And that is going to be equal to I minus 2 times 1. That will just be I minus 2. To remain with z, divide both sides by 21 minus 21. 20i, that will be z is equal to I minus 2 over 21 minus 20i. And then from here, conjugate, since you want to leave your answer in the form p plus qi. Multiply on top by 21, just change the sign plus 20i. Okay? Also down by 21 plus 20i. So z is going to give you I times 21, 21i. I times 20i, that will be positive 20i squared. Negative 2 times 21, negative 42. And then negative 2 times 20i, that will be negative 40i. And then in the denominator, when you are multiplying complex numbers by a complex number is conjugate, get the first one, 21, square it, or it puts a plus. Okay, you get this number that is in front of the I. It doesn't matter whether it's positive or negative 20, you also square it. So z is going to give you, now you know that the I squared here is a negative 1. So this is going to be negative 20, right? So it will be negative 20 minus 42. These are like terms. Negative 20 minus 42, that is going to give you negative 62. And then you have got 21i, negative 40i. These are also like terms. Now the 21i is positive, the 40i is negative. So I'll just say 40 minus 21. I'll remove a 1 here, 3, put there 10. 10 minus 1, 9. So it should be 19. But because it is a big number which was negative, I'm going to put a negative here. Right? So that would be negative 19i. In the denominator, 21 squared, we can easily do that. Plus 20 squared. So 21 squared multiply 21 by 21. 20 squared is a 400. Okay, that is going to give us 841. So to remain now in the form that they want, we'll say therefore, where can I even write? Therefore, z is going to be, I'll just split the denominator to both. Okay, so that will be negative 62 over 841, and then minus 19 over 841. I'll just put an I there. So we've expressed in the form that is wanted. I hope it is okay. Please, if it is not, be sure to ask. Part 2. Simplify and express the surd which has been given here in the form p plus q square root of 3, where p and q are integers. P and q are integers. You want to express them in the form p plus q square root of 3. How do you do that? Now look at what you've been given. You know that for you to be able to simplify an integer, I mean a surd, at least it should be in the form a plus b square root of what? Square root of c. Now look at the denominator. How can you conjugate such a denominator? It is a bit complex. So we should express it in this form a plus b square root of c. Okay? That's the form that you need to express it. And how do you do that? Now the simplest way is this. Look at the numbers that you have in the denominator. I'll just first start with the denominator. We've got 1 plus the square root of 12 plus the square root of 75 minus square root of 108. Okay, so start by dividing by a simplest number that you know in your head. Now, that simplest number should be a square number. The same, what is the simplest square number that you know? Anyone, please. The simplest square number that you know. Simplest square number? 3. Anyone else? Okay. Look at this. If you've got these numbers 1, 2, 3, 4, 5, 6, 7. Okay, yes. If I square these numbers, that result that I'm going to get is what we call a square number. So 1 squared is 1, 2 squared is a 4, 3 squared is a 9. 4 squared is 16. 5 squared is a 25, 36, 49. So these numbers we're able to see here are called square numbers. So the simplest square number that we should think of is a 4, not a 1. Like 1 divided by anything is always itself. So I'm going to say this is going to be 1 plus. So if I divide 12 by a square number, which is 4, I'm going to get what? I'm going to get a 4. So that means that 12 is the same as 4 times 3, all right? And then plus, let's think of 75. Now, since for this one, things were even made much simpler. You know that we're supposed to have a 3 in the root. So all I'm going to be doing is dividing everything in the root by a 3, all right? So 3 divided by 12, I'll get a 4. So it means 4 times 3 is going to give us a 12. 3 into 75, that is going to give us a what? Is it a 25? Okay. So I'm going to write 75 as 25 times 3. And then 3 into 108, that is going to give us a 36. So I'm going to write 108 as 36 times 3. So this will be 1 plus. Now square root of 4 is a 2. So it becomes 2. And then we have got a square root of 3 that has remained. Square root of 25 is a 5. So that would be 5. We have got a square root of 3 that has remained. Square root of 36 is a 6. So that would be 6. We've got a square root of 3 that has remained. So this will give us 1. Okay. Now when you are subtracting or adding sides, just get the numbers that are outside. So we're going to have positive 2 plus 5, which is a 7, minus 6, which is a 1. So this is going to be 1. And then just write the square root of 3. Now, it is not rational writing a 1 in front of the root 3. So the answer is just 1 plus root 3. Okay. So this is the denominator. So I'll write this again. So I'll say 2 square root of 3 over the denominator, that is just 1 plus square root of 3. Now we can conjugate. I multiply on top by the conjugate, which is 1 minus square root of 3. The denominator also by 1 minus square root of 3. So I multiply this by this. That will just be 2 square root of 3. I multiply this by this. Now remember, you get this number, you multiply by the number which is in front, which is a negative 1. That will give you a negative 2. Multiply what is inside also. 3 times 3, that will be 9. And square root of 9 is a 3. We said root a times root a will always give you a. So that will just give us a 3. In the denominator, a number multiplied by its conjugate, a third by its conjugate, get the first one, square it, minus, get the second one, that is the square root of 3, also square it. If it is a complex number, I would have put a plus. So what we have on top, I'm going to start with a number that doesn't have a root. What is that? Negative 2 times 3, that gives us negative 6. All right. So this one, negative 2 times 3 is negative 6. And then I write now 2 square root of 3. In the denominator, 1 squared is still a 1 minus root 3 squared. The root and the 3 is the square cancel. So just remain with the 3. 1 minus 3 is a negative 2. So now it's just split negative 2 into negative 6. That is a positive 3. Negative 2 into negative 2. Into positive 2, that would be negative 1. And then we remain with the square root of 3. So this is going to be the answer then for this one. I'm hoping it is okay. If it is not, please be sure to always ask. Okay, we can look at question 4 because we've almost done all questions that we need to understand. So question 4. In the Venn diagram below shade the set A minus B minus C. The first thing we need to simplify. I'll change first this minus, the first minus we're able to see here, into intersection. So that will be A intersection B minus C. By the B minus C will gain a complement because we've changed the minus into intersection. Again, this will become A intersection. I'll change what is inside to an intersection. It will be B intersection C complement. Okay, and then a complement again. Now again distribute this complement to the inside. That will be A intersect to be B complement. Remember according to De Morgan's law, sign changes to union. Then you're going to have C complement, complement, which is just a C. Now, what you now shading this one, I've got B complement. We'll start with this B complement union C. Remember the Venn diagram have already been given. You want what is outside B but should be in C. Okay, that is a B complement. Sorry, not what is in B but is in C, but this is a union. I thought it's an intersection. So B complement union C means shade everything what is outside B together with the set C. So everything outside B, all this, together with the set C is this. Okay, but all of these things that we've shaded, it needs to intersect with A. Like, where does it meet with A? So see that the only region where they meet with A is just here. So in other words, for this one, all you needed to do is to shade the set A. You'll get the 5 marks. And by the way, simplifying like this also carries marks. I don't know if it's 2 or 3 marks. And then shading also. So you need to make sure that you do it all. And then we have got B. Let A be equal to negative infinity to 3, B be equal to negative 3 to 3, and C be equal to negative 1 to 6. And R be the universal set. Find A intersection B minus C complement. So let's simplify first the set that we've been given. A intersection. I'll change the B minus C to B intersection C complement. Remember, also have a complement outside. Okay, a complement outside there. Again, I'll distribute this complement so that will be A intersection B complement. The sign changes to union. And then we're going to have C complement, which is just C. So now we can now start working it out. So the first thing that I'm going to do, so I'm going to start with the B complement. Where is the set B? B is from negative 3 to positive 3. Now you can see that negative 3 is part of B. That means it will not be part of the complement. Okay? And then 3 is not part of B. That means it's going to be part of the complement. Now, if you can see for this one, I'm just putting arrows because the universal set has been is not restricted. The universal set is a set of all real numbers. That is why I've put arrows. Otherwise, if we knew the bounds or the limits of the universal set, I would have just gone to where the universal set ends. So this is B complement. And then now you look at the set C. What is the set C? It's from negative 1 to 6. Negative 1 will be somewhere here. 6 is going to be somewhere here. Can see we are not including either negative 1 or 6. So this is the set C. Now we want the union of these sets. Union means combine them. So we are going to combine the whole of this and this. So if you combine, you see it will continue going like that. Like this C has joined with a B complement this side, making just a long line from here going direct like that. So the arrow point like that. And then we are from negative 3 also going like this. So this is the what? This is the B complement union C. Now we're going to get the set A. Set A is starting from 3 going to negative infinity. 3 is here, here, going to negative infinity. Negative infinity is in this direction. Or the set is coming from negative infinity to positive 3. We're not including 3. So this is the set A. Now I want the intersection. Where are these meeting? You can see that these are going in the same direction. So all this direction they are going to meet. Okay, they are meeting all this direction. And then up to this point, they are still meeting. But here they don't meet like this. Here they don't meet. And then they meet from here up to here again. Okay, so this is the set. So we can now put it. A intersection B minus C complement. We can see they are all coming from negative infinity. Negative infinity shall never be included in a set, so always use open. And then comma. Where are they ending? They are ending here. Now you can see that this set here is open. So obviously, even if 3 is part of this other set, negative 3 cannot be part of the intersection because it is not part of this set which is on top. So we're going to open. And then we put a union. Okay, why are we putting union? Because we also have this point here, which is an intersection from -1 up to 3. Now I can see this is open, so this is going to be open. This is also open, so this is also going to be open. So this is a set. A intersection B minus C complement. Right. Now we can look at part 2. Let the operation star be defined on the set of real numbers as a star b being equal to a squared minus b squared. Now you want to compute 2 star 3 star negative 2. 2 star 3 star negative 2. First thing is work with what has been given in the bracket. So this is going to be 2 star. Okay. Now you work out this. You are going to, now you know that the operation, this is going to be 3 star, this is going to be -2. That means where there is A, we're going to put a 3. And then where there is B, we're going to put -2. That's all you follow. So that is going to be 3 squared minus -2 squared, and then you put that. So be 2 star. 3 squared is a 9. -2 squared is a 4. So give us 2 star 5. Okay. Again, you know the meaning of 2 star 5. You get the first number, you square it, minus the second number, you square it. So 2 squared is a 4, 5 squared is a 25. That gives us -21. So this is it. And the very last one for today here. Simplify the set as far as possible. P minus Q as far as possible. So you have P minus Q. Actually, there's a complement outside there. So the first thing, I'm going to change this into intersection. Becomes P intersection P minus Q. Remember, a complement is going to come here, but there's also another complement. So those two complements cancel themselves. That would be P intersection P minus Q. Again, we change what is inside to an intersection. That would be P intersection Q complement. Okay, there. Now, you want where P intersects with P intersection Q complement. In other words, you need to know which one of these two is a bigger set. Now, when you are simplifying sets, like in the simplest form, you shouldn't see the same letter twice. So we can't see P here and P here. That means we've not simplified. So to simplify, I can just use the Venn diagram. Here is P, here is Q. I can first start working with this one. P intersection Q complement means what is in P, but it should be outside Q. Okay, it is in P, but it is outside Q. This is the region. If it was union, would have shaded even the outside. And then we want where it intersects with the set Q. Where does it intersect? I mean, with the set P. Where does it intersect with the set P? What is the set P? The set P is the whole of this. Now look for the intersection, like the common region. You can see that the common region is just what? Is just P intersection Q complement, because P intersection Q complement is a smaller set as compared to P. That is why their intersection, you always get a smaller set. So that is going to be it.